Hello and welcome to Identify Technical Debt. I'm Andrew Conniff, a Microsoft Technical Trainer specializing in data and AI, and today we're going to explore how to identify and manage technical debt in DevOps practices. Let's dive right in. Code quality is essential for building software that is clear, maintainable, and secure. So when teams face short deadlines, lack coding standards, or have limited technical skills, the resulting code can be difficult to read, poorly documented, inefficient, and hard to extend or protect. High-quality code should be easy to understand, be well documented, and designed for future growth, so ensuring that it remains robust and secure as the project evolves. Understanding code complexity is crucial for maintaining high-quality software. Let's talk about the key metrics that help developers assess how challenging their code base might be to work with. Important measures include program vocabulary, which is the variety or unique elements used, calculated program length, which is the total size of the code, the volume, the overall amount of information contained, and the difficulty, how hard it is to understand or modify, and the effort, the amount of work required to develop or maintain the code. By regularly evaluating these metrics, teams can identify areas where their code may become too complicated, making it easier to improve the readability, maintainability, and overall software quality. Technical debt refers to the implied cost of additional rework caused by choosing an easy solution now instead of a better approach that would take longer. It accumulates when teams prioritize speed over quality, often under tight deadlines. While this can accelerate the delivery, it introduces hidden risks that can impact maintainability and scalability. So managing technical debt involves recognizing trade-offs and implementing strategies to reduce its impact. Common practices include code reviews, automated testing, and refactoring. And by addressing technical debt early, we can avoid costly fixes later and maintain agility in our software development. To effectively manage technical debt, it's important to measure it using clear metrics. Some useful indicators include the percentage of failed builds and deployments, the volume of tickets or bugs, bug bounce percentage, which is how often bugs reappear, and the amount of unplanned work. By tracking these metrics, teams can identify areas where technical debt is accumulating and take proactive steps to address it. Automated testing and assessments are valuable tools for minimizing technical debt. It helps teams maintain high standards and deliver reliable software that meets user expectations. And technical debt can sneak into a project from many directions, often as a result of shortcuts or rushed decisions. Common sources include a lack of coding standards, poorly designed unit tests, ignoring object-oriented principles, and leaving behind monolithic code or dead code or commented code that's not doing anything. Over-engineering, insufficient documentation, and not writing self-documenting code is also a contributing factor. These issues can slow down future development, make code harder to maintain, and ultimately impact the quality and reliability of the software. By understanding where technical debt comes from, teams can take proactive steps to minimize its impact and keep the projects healthy and sustainable. One of the most effective ways to keep technical debt in check is through automated testing and assessment. By regularly running automated tests, we can quickly spot issues, validate changes, and prevent small problems from growing into major obstacles. This proactive approach helps maintain code quality, boosts team efficiency, and ensures that software remains reliable and easier to improve over time. DevOps pipelines and workflows can be seamlessly integrated with a variety of code quality tools to help our teams maintain high standards throughout the development process. Tools like NDepend or ReSharper provide automated analysis, measuring the technical debt and identifying code quality issues before they become bigger problems. For example, NDepend is a Visual Studio extension that assesses technical debt added during recent deployment, while ReSharper code quality analysis can be set to automatically fail builds if code quality issues are detected. This proactive approach ensures that only high-quality code makes it into production, saving time and reducing the risk of bugs. GitHub Advanced Security is a powerful suite of security features designed to help development teams keep their code safe and maintain high standards. With GitHub Advanced Security, you get tools for code analysis, dependency management, advanced code reviews, and scanning for secrets and vulnerabilities. These features work together to identify risks early and provide actionable insights and help teams remediate technical debt before it becomes a problem. GitHub Advanced Security integrates seamlessly with GitHub and is also available as an extension for Azure DevOps, making it easy to add robust security checks to your existing workflows. Another benefit of GitHub Advanced Security is its ability to automate security and quality checks so teams can focus on building great software without worrying about hidden issues. By continuously scanning code and dependencies, GitHub Advanced Security helps you discover vulnerabilities and technical debt, offering detailed recommendations for improvement. This proactive approach not only strengthens your code base, but fosters a culture of security and reliability across your organization. Code reviews are a cornerstone of building better software and fostering a collaborative team environment. The main goal is to improve code quality by having team members review each other's work, catching bugs early, and sharing knowledge across the group. The process isn't just about finding mistakes. It's about learning from one another, discussing different approaches, and making sure everyone understands the code base. When teams regularly review code, they build trust, encourage open communication, and help everyone grow their technical skills. Effective code reviews also create a culture of continuous improvement. By sharing feedback and insights, teams can spot patterns, identify areas for improvement, and ensure that the best practices are followed. This leads to more maintainable, reliable, and secure software. Plus, code reviews help prevent technical debt from piling up, making future development smoother and less stressful. In short, planning and conducting thoughtful code review is one of the best investments a team can make for long-term success. Let's move to a demonstration where we use these tools to identify some technical debt. Let's talk about branches. Let's start with a typical workflow where we start with our work item. I will mark it as in progress and assign it to myself. I can view what the top level item is, and I'll save my changes and then create a branch. I want to give my feature branch a name that shows the feature and the work. Now let's make a change to our code on our branch. To keep it simple, let's change the README file. Let's switch to our branch and make a quick edit. Once we have our changes, we will commit the changes. We'll add the work item 9. Let's go take a look at our feature branch. Notice the folder structure showing the feature and all the branches under that feature. The next step is creating a pull request. When completed, our changes will be merged from other branches into the main, and our feature branch will be deleted. Now let's look at how to secure our main branch and set some rules. In branches, we go to the main branch and select the ellipsis on the far right. Then we select branch policies. Once we select branch policies, we will not allow any direct check-ins to the main branch. Here we can set who can approve changes and how many approvers are required. We can add required approvers based on file path or the whole repository. Now we will see the required approvers and work items in the pull request. And the code checks in. And here we see the fork our code option in the inner source or open source repository cloning. In GitHub, we see the fork in the repository. We set our branch policies using the repository settings. Selecting branches on the left brings up the branch rules. Here we can see a variety of options we can choose from. If you'd like to go deeper and run the AZ-400 lab exercises using your own accounts and subscriptions, you can find the self-paced labs on GitHub at Microsoft Learning at /mslearn-devops. And if you prefer structured guidance, you'll also find options for instructor-led AZ-400 training with live labs and expert instruction on Microsoft Learn at the AZ-400 course page. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.